For example A, we have that x plus 3 times x minus 3. Your A is the x, your B is the 3. We're going to do A squared minus B squared in order to get this binomial, these two binomials multiplied out. So your A, we said is x, you're going to square that, minus your B, which is 3, you're going to square that. Your x squared is x squared, your 3 squared is 9. The negative stays between them, so you just have x squared minus 9. For example B, we have 2n plus 5 times 2n minus 5. Again, your first term is that A term, so A is 2n. Your second term from each set of parentheses is your B term, so that B is 5. You have opposite signs between them, so use A squared minus B squared. That A squared is 2n squared, that B squared is 5 squared. So the 2n raised to the second power is 2n times 2n, which is 4n squared. And that 5 squared is 25. So we have 4n squared minus 25. For example C, we have 5x minus 3y times 5x plus 3y. Your A from each of these is the 5x. Your B from each is the 3y. So A is 5x, B is 3y. We do have a negative and a positive, so opposite signs between these two A and B terms. So we are going to use A squared minus B squared. Our A squared is going to give us 5x raised to the second power. Our B squared gives us 3y raised to the second power. 5x to the second power is 25x squared, minus 3y to the second power is 9y squared. For example 2, we're doing the same exact thing. For A, we have A squared minus 2B times A squared plus 2B. Again, you have opposite signs between these terms. Your A is the A squared, your B is the 2B. So A is equal to A squared, B is equal to 2B. We're going to use A squared minus B squared. So this is going to be A squared raised to the second power minus 2B raised to the second power. The A squared raised to the second power is A to the fourth power, and 2B to the second power is 4B squared. So A to the fourth power minus 4B squared. For example B, we have xy plus z squared times xy minus z squared. Your A is the xy, your B is the z. You have opposite signs between those. Sorry, z squared, not z. So use A minus B, A squared minus B squared. So this is going to give us xy raised to the second power minus z squared raised to the second power. So this is x squared y squared minus z to the fourth power. The second half of your lesson goes over factoring these binomials. So these binomials, you're going to look at them and you're going to ask yourself, can I take the square root of the first term? Can I take the square root of the second term? Are they separated by subtraction? For example A, you have x squared minus 49. Your A is going to be the square root of that x squared. Your B is going to be the square root of the 49. The square root of x squared is x. The square root of 49 is 7. Because you can take the square root of both of these terms and they are separated by a negative, you are going to use A minus B times A plus B. So we said A is x, B is 7, so that's x minus 7 times x plus 7. For example, B, we have 16 minus 9x squared. So again, our A is going to be the square root of that 16, which is 4. Our B would be the square root of that 9x squared, which is 3x. There's subtraction between the two, so we're going to use A minus B times A plus B. So this is going to give us 4 minus 3x times 4 plus 3x. For C, we have 81a squared minus 25x to the 6th power. Our A we can find by taking the square root of that 81a squared, which is 9a. Our b, we can take the square root of the 25x to the 6th power, which is 5x cubed. Again, we're going to use a minus b times a plus b. So this is going to give us 9a minus 5x cubed times 9a plus 5x cubed. Last part of your lesson, you're working with factoring a binomial where just factoring it once is not going to factor it completely. So if you look at example 4, we have 16r to the 4th power minus 625. If we find our a by taking the square root of 16r to the 4th power, that's 4r squared. If we find b by taking the square root of 625, that's 25. If we use a minus b times a plus b, this gives us 4r squared minus 25 times 4r squared plus 25. Now you have to ask yourself, I have two binomials. Do either of those binomials have a subtraction sign that separate the two terms in them? The answer to that is yes. The first one does. The second one does not, so you cannot do anything else with that second binomial unless you can factor out a greatest common factor from the 4 and the 25, which you cannot. So leave that one alone. For the 4r squared minus 25, check to see if you can take the square root of both of those terms. For a, the square root of 4r squared, you can do, that's 2r. For your b, that would be the square root of 25, which simplifies to be 5. There is subtraction between those two, so again, use a minus b times a plus b. So this is going to leave us with 2r minus 5 times 2r plus 5 times 4r squared plus 25. So if you can't simplify or factor one of those parentheses, it has to stay part of your answer. It doesn't just disappear. It does stay with your answer. So you have to make sure you include that with your answer.